Good morning, everyone. Welcome to the first of our four-part webinar series on secure development on the Salesforce platform. So we're going to talk today about a few topics of secure development in Salesforce, Apex, Visualforce, and so on. And we'll also introduce the webinar series itself. So first, I'm Max Feldman. I'm a product security engineer here at Salesforce. I work on a few different things here, some of them internal, some of them tools. And I also work on App Exchange and App Exchange security reviews. So if you've ever submitted, if you're a partner and you've submitted an App Exchange app for security review, or if you've phoned into our office hours, you may have dealt with me before.
Hi, my name is Lihan Huang. I'm also on the product security team. I recently joined, but I've been doing some App Exchange review, some internal tools development, and security reviews with internal teams.
Hey everyone, I'm Vinay. Same as Max and Leon, I work in the product security team. My responsibility include working on the App Exchange applications. I'm also a developer. I use the Salesforce platform to build some internal tools and partner automation tools. I also help the internal teams with anything related to security.
And a quick legal statement, don't make any investment or purchasing decisions based on this talk. We're not covering any new features, we're covering things that exist and how to do them securely, but yeah, don't make investment or purchase decisions based on what we say in this talk. Also, you can follow us on a bunch of different social media outlets. There's @SalesforceDevs or #ForceWebinar on Twitter. There's a Facebook, LinkedIn, and YouTube for Salesforce developers. And also, this webinar is being recorded, so we'll do Q&A at the end, but feel free to ask questions during. All those will be recorded along with the content itself, and we'll also release the slides and the code that we use in our demos. Yeah, so if you have questions, don't wait until the end to ask your question. We have people monitoring our queue, so if you ask questions, we'll be getting to them in a good order. If they're urgent, we'll address them during the presentation. If we think they can wait, we'll hold them until the end, and we'll go through the queue of questions in the Q&A portion. And stick around for that live Q&A at the end, so we'll handle more questions. We've allocated some time for that, so we should have a good amount of time to address any questions or other things you'd like to address. And if you have even more questions, you can head to the Salesforce developer forums. People from Salesforce monitor that, as well as Salesforce experts, and you can get a lot of good information there. So our agenda, our roadmap for the year is that we're going to have 4 webinars. We're going to have 1 per quarter. So this is the first of that 4-part series. Today, we're going to talk about the secure development lifecycle, Crud and FLS, sharing, Soql, and then we'll have a Q&A session. Later in the year, we'll talk more about secure secret storage, secure callouts, how to deal with APIs, things like that. And today, we're really going to focus on access control and how that applies in Apex and Visualforce. We've introduced ourselves, Max, Lihan, and Vinay. So a bit of introduction just about security and the Force.com platform. So Force.com was designed to be flexible and support developer and business needs. It is very powerful, and through that flexibility and power, it is sometimes possible to shoot yourself in the foot. So we're going to discuss when we present security issues, we're going to discuss how to prevent them and how to provide access checks or provide security despite the power that Salesforce gives you. Force.com provides a lot of built-in protections to protect developers and their user base, but sometimes you need to use particular code or particular design patterns to provide additional security. And Salesforce protects all of our end users and your end users, if you're a partner, by ensuring that all applications listed on the App Exchange undergo a security review. So if you're a partner, you may have done this already, but when you release an app, it has to pass security review. So the things we talk about here will be important for passing parts of that. If you've ever had a security review fail for Crud, FLS issues, or sharing, we'll talk about how to mitigate those, and hopefully it'll be useful when you're trying to list your app. It'll also be useful even if you aren't listing an app, but you are writing code for your org, you want to make sure that your organization is run as securely as possible. And a bit of background on the security issues we're going to address today. So the principle of least privilege is an important facet of access control, and it states that users should only have access to the minimum amount of information required to accomplish their duties. So a user's ability to take advantage of excess privilege, purposefully or accidentally, should be minimized. And an important aspect as it applies to Salesforce and Apex are the two contexts in which code can run. So there's user context, which enforces user permissions, field level security, and the sharing rules of the current user. This is basically least privilege is applied, and users can only access what they should be able to access. And you'll see this if you're viewing a page like a standard object or such as an account or something within Salesforce itself. System context is more powerful. It ignores user permissions, field level security, and rules of the current user. And a lot of the ability of Apex to allow you to shoot yourself in the foot stems from the system context, because Apex runs in system context. So we'll see this repeated throughout the presentation. So an important part of developing your project, going from idea to release, is the secure development lifecycle. So there are 4 parts of this. There's design, in this phase you just want to plan your application with security in mind. When you're architecting things, when you're laying out how parts will interact, you want to keep in mind access control, who can see what, and we'll see in further webinars what other aspects of security you'll want to keep in mind when designing. When you reach the development phase, you'll want to follow the best practices for secure development and practice secure implementation. And for both of these, we have some resources in the slides to our security pages. We'll have more resources later in the presentation. When you're doing testing, you'll also want to test for security. It's pretty standard to test for functionality, to have unit tests, things like that. But you'll also want to test for security. You'll want to make sure that security decisions you've made are properly enforced. And finally, you'll reach the release phase. You'll release your project to the public or to your org, and you want to be prepared for the discovery of any security flaws. So you need to be able to address issues if they come up, and you'll need to be able to patch them and re-release. Staying secure is an ongoing process. So as you release more features, as you develop new parts of your project, you'll want those to be secure as well. And with that, we're going to hand it over to Lihan to talk about the demo application that we'll use today to illustrate the security issues we'll be talking about.
So today we have a very simple application that we named ForZip. So what it does is it'll take the 5-digit US zip code from accounts, in particular the shipping address, and we'll grab that 5-digit code, make an external call, and get the 4-digit extension. And also, the app itself is just one page. It's going to display the account, the opportunity, and annual revenue of the accounts.
And there was a question about Apex running in system context. Is that always the case? And yes, it is. Apex always runs in system context, so we'll talk about how we have to enforce access control patterns.
For today, we're going to be visiting the ForZip app with 2 different account profiles. First of all, we have the system administrator. This is the default administrator profile and has access to everything. We'll be looking at and also editing the Apex and Visualforce pages with this account. Next up, we have the ForZip user that will use to demonstrate vulnerabilities. So this is a clone from the standard user because we need to modify some access for this account. For example, we limited restriction viewing to opportunity that cannot see opportunities. We'll go over this in detail later. But this account should also have the same visibility in, say, if you go into account tab, also in the ForZip app. So what will we develop today? We're going to have one Visualforce page to display the information, one Apex controller, and inside the Apex controller, we have a couple things. So we have a mock API call for the external call to get the 4-digit extension. For today, we're just going to do a mock call and return 1, 2, 3, 4. because in part 3 of the webinar series, external application and system integration best practices, it is best covered there. We'll talk about how to securely store credentials, how to securely make API calls, and then we'll come back and visit this application. Next up, we have wrapper classes to hold the zip +4 information and opportunities. The reason why we have wrapper classes is so we can hold additional 4-digit zip. That's not in the standard account object in Salesforce. So we're going to just make a wrapper class so we can hold additional information. Now let's take a look at the code. So here we have the system administrator account. We can take a look at the code in just the developer console. So we have the controller here. It's very simple. We have, for the controller itself, we have just 2 variables to hold information. So we have the search string that we're going to use for the search query to display accounts. We have a list of account wrappers to hold the accounts that we're going to display on the page. So the account wrapper itself, it's only going to store relevant information. We don't need to grab everything from accounts. So we just have the name, the full zip, and the revenue. We also have a list of opportunity wrappers because we're going to display the associated opportunities. Whenever we get an account, we're just going to use this constructor to make the account wrapper. So we grab a name, we put in the name. For the full zip, we're going to take the shipping zip code from, shipping postal code from the account. We're going to append get zip4, which is a function here that I mentioned. We're going to come back and develop more to get the full zip. In opportunities, we're going to do this. Revenue, same thing. We'll grab the annual revenue. We're going to format it so it looks nicer with the $ in front and the comma in correct places. Opportunity wrapper, very similar, except we're only going to have the name and the amount for the opportunity. So this is the helper function, just to format the revenue. So this is the actual search account functionality. So what this does is, what the user is going to do is they're going to submit a search query on the Visualforce page, and we'll take that query. We're going to put it inside our Soql query here. So this is the Soql query. We're going to retrieve a couple stuff from the account object. So from account, we'll name like our search query, and then we're going to put it to the database and get our accounts. Next up, we'll grab the associated opportunities. And for each account that came back from the query, we're going to make an account wrapper because we need the revenue and we'll also need the full zip. And then for each opportunity that's inside the account, we'll also put in the opportunity wrapper, and then we'll just return the list of the account wrappers. So this is the Visualforce page. It's very short, very simple. We have a search box here to put in our search query. When we click search, it's going to do the search account functionality in the zip4 controller. And the result we're just going to display in several columns. We have the account wrapper with the revenue and the opportunity, the opportunities, and the amount. And on the very right, we have the zip code. So this is a screenshot of what the system administrator sees. Like the Visualforce page, you can see we have the account, the annual revenue, the opportunities. Some of them don't have opportunities, and then the zip code with the 4-digit extension. This is what the 4-zip user should see. You can see that it's limited in the fact that it cannot see any opportunities and it can't see the annual revenue. And with some sharing rules, it can only see 2 of all the accounts that we saw in the system administrator profile. Right now, it's not going to look like this, but as we go through the webinar today, we're going to do all the fixes so that it eventually ends up with just these accounts.
Let's talk about Crud.
And so we had another question real quick about the last method returning null in the Apex controller?
So basically, why we return null is because we can refresh the page and show the results. If you return a URL, it's going to navigate to that particular URL. So we're going to return null and refresh the same page. So let's talk about CRUD. CRUD stands for create, read, update, and delete. So basically, every user in Salesforce has some permission associated to him. It's actually stored in profile or in permission sets. So if you go to a profile of a particular user, or if you go to a permission set of that particular user, you can see what permission he has for certain objects. For this example, you can see that this particular user, who might be a sales rep, might have read, edit, and delete access on accounts, but he can't create accounts. But in terms of campaigns, he can create campaigns and also read campaigns. There are some elevated privileges, such as view all and modify all. This is usually for system admins or who have some other users who have elevated privileges. So since administrator will go and set up all the CRUD, we as developers need to respect that CRUD when we do some coding and we have Visualforce page or Apex classes. So in general, Apex classes do not enforce CRUD. So it's the responsibility of the developer to enforce CRUD. But if you have a Visualforce page without any Apex controller, we just have a standard control like an account, it automatically enforces CRUD and you don't need to worry about it. But let's say you have a Visualforce page and also an Apex controller. You're passing data from an Apex controller to a Visualforce page. Here, if you pass data, if you're directly getting the data from an account, not modifying it and passing it to the Visualforce page, the CRUD is respected. But let's say you have a wrapper class or you convert it to a string and then pass it to a Visualforce page, the CRUD is not respected, and you need to make checks in the controller to make sure that the CRUD is respected. Let's do a quick demo in our application to demonstrate this vulnerability. So we have the zip4 user here. There's a system admin. I'll just show you the zip4 user's profile and what permission does he have. So I'll go to the users tab. So go to the zip4 user, go to the profile. Now I'll go to object settings. Here, for opportunities, you can see that this particular user has no access. That means he should not be able to see any opportunities in this arc. But on accounts, he does have read, edit, create, and delete access. That means he can read his own accounts. Now we have created a Visualforce page. Let's see how we have developed it and what data can we see. I've logged in as a normal user here. I'll go to the Visualforce page that we have created. I'll search for a sample string uni. You can see that he's able to see opportunities, even though in a CRUD he should not be seeing all these opportunities. This is because there's a problem in the Apex class which is allowing more information should be shown. We need to fix this problem. Let's figure out how do we fix this problem.
So how will we fix this problem? We have had to enforce CRUD in Apex. Luckily, it's pretty straightforward to do so. Each of the 4 operations in CRUD has its associated method that we can use to see whether the user has access to it or not. So for CRUD, we have creatable, we have accessible, is updatable, or is deletable. To do so, you can use the sample code like this below. So in your controller, all you need to do is get the object type and check whether it's accessible or not, or whatever operation you're trying to perform. So in this case, we're going to see if a user can access the account object. So we'll just do account.sObjectType.getDescribe.is accessible. If the user can access it, this will return true. So in this case, if you can't access it, so if not true, we'll return nothing. And if true, we'll do some operation and possibly return that to a Visualforce page. So onto the Visualforce page, how do we enforce this? Like Vinay mentioned, if you just leave it in the S-object context, it will do so automatically. So in the top 3 examples above, there's different ways of writing the code, but in all 3 of them, it will automatically be enforced because you can see that we're using the S-object itself and calling the field. So even though this is a custom field, we can still enforce it automatically. The system will be able to read from the profile and know whether this user can see it or not. However, if you take that object out of the S object context, so you put it here as an S object or here as just a normal variable, Visualforce no longer knows what context this is in, so it's just going to display this as if this was a normal string or a normal number. So now that we know how to approach this problem, let's go ahead and fix it. I'm going to pull up the developer console again to do the fix. Now let's take a look. So the issue we had was that the Zip4 user could see opportunities when it's not supposed to. So where was this return onto Visualforce? Right here. We're not checking whether the user has access to opportunity before we add it to the list that was returned to the Visualforce page. So we'll probably need to do something here, a conditional statement to see if the user can access it. So here we have the fixed version. As you can see, before we add the opportunity into the list of opportunity wrappers to return, we do a little check here. We're checking for opportunity. So we do opportunity.sObjectType.getDescribe.is accessible. If so, we're going to add it. If not, nothing happens. Same goes for the account object. Do account is accessible. If so, add it to the account wrapper or add it to the account list. If not, it doesn't even go through the opportunity object and it'll just return an empty list. So now, let's point our Visualforce controller to our Visualforce page to the correct Apex controller, and we'll go back to the Zip4 user and see if the issue has been remediated. So if you remember before, we were able to see a bunch of different opportunities. However, now you can no longer see it. It's because we're now making the correct check, and it won't display any opportunities to this user because it has no access to this profile. So just some best practices to remember. You should always do the check Crud permission checks in your Apex class, just as a best practice, because you never know what the Visualforce page will do. It's just best to not pass the data to Visualforce if the user doesn't have access to it. If you don't do so, you can really give elevated access to users that do not have it, and that's not a good thing. So next up, let's talk about FLS.
So FLS stands for field level security. It's the same thing as CRUD, but it's for each object, each field in the object, and this is also defined in the profile or permission set. So in every object, for example, accounts, each field can also be configured to be visible or read-only or editable. For example, in this particular screenshot, you can see that account number is visible and editable, and so is account side, account source, but created by is by default read-only, and the user can't edit that field. So using this, we can see that the particular user will have certain permissions for particular fields, and the admin can set this up. For us developers in field level security, we need to make sure that we respect whatever the admin has done. In Apex classes, we do not enforce the Apex classes do not enforce field level security. This is because it runs in system context, but Visualforce page by default, as same as CRUD, does enforce field level security. So for example, you can see that you have contact.email. In this particular thing, you're getting contact from Apex class and directly passing it to the Visualforce page. And this basically, the field level security is respected, and you don't need to make any checks. But if you have a variable called contact email and you're changing taking the email and then putting it in a string and then passing it to a Visualforce page, then the CRUD is not respected, and here there might be vulnerabilities.
And a quick interjection, a couple questions were asking us if we could fix these issues using with sharing. We'll talk more about sharing soon, but the short answer is no. Crud, FLS, and sharing all cover different types of access, and they restrict or allow it in different ways. So we'll get into more depth soon.
Okay, so back to the FLS demo. Let's go back to the system admin user. Let's go to accounts, and for accounts, you can see that this particular user doesn't have access to read or edit annual revenue. So if you go to any account from this user and try to find annual revenue in the list of fields, it is not present. But let's look at our Visualforce page that we have created. And we do the same search. We search for me. You can see that he's able to see annual revenue even though the FLS for his particular profile restricts him to see that. So this is a problem, and you need to fix this. And let's figure out how to fix this problem.
So the way to enforce FLS in Apex is actually very similar to enforcing Crud. However, in this case, we only need to worry about whether the user can see it or the user can update it. So we just have two methods here. We do, let's say, for example, we want to check if the user has access to the account's name field. So we'll just do schema.sObjectType.account. So this is the object that you want to check. .fields.name, and this is the actual field we want to check. Is accessible. If not, we'll do nothing. If so, we'll do some operation and return it to the Visualforce page. So when does the platform stop respecting FLS? Again, just like Crud, if you take it outside the sObject context, it no longer knows where to check for the permissions, so it'll just return it as if this was a normal value that you put on the Visualforce page. So this example here, we have several things. So first of all, in our Apex controller, we have random sensitive object. So this is a custom object that is sensitive. And we have some kind of permission set in the profile, so some user can see it and some user can't. And next up, we have a wrapper object. It is the same exact object as the random sensitive object here, except it's a wrapper that we created in Apex and is not inside Salesforce. So what we do here, we're going to take the sensitive number from a random sensitive object. We're going to put it inside our wrapper object with the same exact name. When you put it into Visualforce, even though these two Apex tags are the same, the value should be the same. On the first one, FLS is respected because the system knows where to get the information from the sensitive number field. It knows where to check whether the user has permission or not. However, in a wrapper object, it does not know. So it'll see the value and it'll just display it. Now that we know how to approach the problem, let's go and fix it in our 4zip application. Before that, let's talk about the issue in our controller. So we needed limit access on the annual revenue field, and that is done in the account wrapper constructor. When we get the accounts, we pass it into, if you remember, we pass it into the new account wrapper as constructor, and we do something to the list. So here, we're grabbing the revenue here. I made a note that this is the FLS violation here. We're not checking whether the user accessing the page can see this field. So we need to do something here before we pass it down. So it's very simple, just an if statement here. If the user can access the account's annual revenue field, we'll actually pass in the annual revenue inside the revenue variable in the account wrapper. If not, there won't be an annual revenue variable. So we'll fix our Visualforce page. This is as if for user again, and we'll search for the same accounts. Now it can no longer see annual revenue because as this user, the Apex controller won't pass in the annual revenue to the account wrapper, and on the Visualforce page, there won't be any data to display. Before moving on, let's talk about some best practices. Again, make sure you keep the object context inside as object references whenever possible. That way, Visualforce can automatically do the heavy lifting for you and do all the permission checks. And again, in your Apex controller, make sure you iterate through the list of fields and check FLS for each field, whether you're going to display it or update it before putting it on the Visualforce page to prevent any privilege escalation issues.
Cool. And so with that, we're going to bring it to sharing. So hopefully when we talk about sharing, we'll clear up some of the questions we've seen about Crud FLS, and if adding with sharing will fix things. We will talk about the with and without sharing keywords. And another point to make about the app, we've had a couple questions asking why things weren't enforced by default, or asking about some of the code patterns. We've gone a little bit out of our way on this app and not necessarily followed the best design practices so that we can show some of these vulnerabilities. Some of the issues stem because we wanted a wrapper object. As we stated earlier, we have a wrapper object around to include that extra 4 digits on the zip code, so that wrapper gets rid of some of the default security and the implicit security that Apex does for us. So that's, if you have questions, and we'll be sharing the code later as well, so if you want to pour over the code later, we'll make that available in both its secure and insecure forms. Just keep in mind that it's not necessarily the best way it could have been coded, but we didn't go out of our way to make it terrible. It's just kind of a mid-level app. So that brings us to sharing. What is sharing? Sharing is record level object. So we had Crud was object level, FLS is field level, and sharing is record level, an instance of an object. So sharing dictates which records of an object a user can see. It's controlled outside of the profile via org defaults, roles, ownership, and sharing rules. So here we see we have some this might be our org configuration, and we've set leads default access to private. That means that the only people who can view a particular lead are the individuals who create it or people with whom it has been shared. When we look at account, contract, and asset, that's set to public read only, which means anyone can see an account, but only people who created it or have had it shared with them can edit that object. So how is sharing enforced? Apex classes do not enforce sharing by default. Apex runs in system context. There are a few exceptions here. So anonymous code blocks, the developer console, and standard controllers execute in user context and enforce sharing here. So we said earlier that Apex always runs in system context. There are a few teeny exceptions to that, but whenever you're writing custom controllers, custom code, it's going to be in system context. And Visualforce pages depend on controllers for record access, so there's nothing to worry about with the Visualforce page itself for sharing access control. It's just the Apex. So here's a little chart to kind of explain where sharing, Crud, and FLS meet. So we'll start with Crud. We've got our spreadsheet here, and it has all of our objects, and each object has a few fields, and every object has an instance. So Crud affects the object type itself. So contacts is an object. Accounts are objects. Opportunities are objects. Crud controls access to that object as a whole. FLS controls access to fields on that object. So title is a field of a contact. Mailing street is a field of a contact. Mailing city is a field, of the contact object. And so FLS dictates that access control. Sharing controls individual records. So Jason Price, Senior Sales Director, is a record. It is an instance of an object which has many fields on it, and sharing controls who can access that particular instance. So someone may be able to may have CRUD access on contacts, but they're sharing restricted to only what has been shared with them. FLS may come into that as well, but all of these have some similarities, but they're not the same, so using with sharing doesn't necessarily fix an FLS or CRUD problem. So now we're going to do a demo of sharing and how it applies in our app.
Okay, so let's get back to our demo app. I'll log in as the sysadmin. Let me look at the sharing settings. You can see that for account object, it is set to private. That means each user can see only his records or records that are shared with him. So you can, if you can go to accounts as a sysadmin and view all accounts, you will be able to see all the accounts. But if you log in as a normal user and go to all accounts, you will be able to see only 2 accounts. And this needs to be respected in the Visualforce page that we have created. But if you search for something like Uni, it's giving out more information than it is the number of accounts that are there. Here I can see that only United Oil and Gas is there, but here I can see Edge Communication and United University of Arizona, which should not be in this list. So let me do a search with empty string. These are all the accounts in the system, and I'm able to see all of them, even though my CRUD permissions or my sharing permissions disallows that. So let's see how to fix this vulnerability. So basically in Apex, if you want to enforce sharing, you need to use with sharing keyword while declaring the class. So basically you need to use something like public with sharing class and your class name. If you don't want to enforce sharing, you need to use without sharing. But let's say you have a class which doesn't use the with sharing or without sharing. Here it's going to run by default without sharing. We'll show that in our example. And also, but there is a caveat there. Let's say it's run if you're not mentioned with or without sharing. If you're referencing the class, that class is referenced in some other class, and that class runs with sharing, then this class will also run with sharing. And also one more thing to note, that the sharing setting of the class is applied when the class where it's defined and not where it's called. So let's say you have a method in a particular class and it's running without sharing, and you reference that in a with sharing class, it's going to run without sharing. In this particular code, you can see that for the top class public, it's running with sharing, and you have some logic which you want to run without sharing. You can declare another inner class, or you can declare a separate class and put the code in there and try to reference that. So let's fix, with this knowledge, we can go and fix the vulnerability in our code. So I open developer console. By default, we can see that it's not running with or without sharing. As I said, that means that it's running without sharing. So I'll open up a fixed version of ours. So you have here, this particular class is running with sharing, and this should respect sharing rules that are defined in the admin by the admin. So we'll change the Apex controller to point to this class instead of the vulnerable class. Okay, let's go back to our Visualforce page and try to search for string unit. You can see that only one record is shown. Now, if I search for the empty string, it just returns 2 accounts, which is the same as the accounts which are supposed to be shown in the accounts page. Before we wind up this topic, let's talk about some best practices. So basically, when you're using sharing, make sure to explicitly declare with or without sharing in all the code. If you don't declare it, it depends on how it's called, and it may lead to some problems in the later future. And let's say you want to run some code without sharing. Document the reasoning in the comment line so that other developers in your team can know about it. And one more thing to know, as one of the people asked, sharing and CRUD FLS are 3 different issues. So make sure you fix each one of them separately. Fixing sharing doesn't fix CRUD and FLS. This leads us to Soql.
So one more topic we would like to cover today is Soql. So what is Soql? Soql is a Salesforce object query language. It's similar to the standard SQL structured query language in some regards and different in some others. The Soql is the language that we exclusively use in Salesforce platform, and it only allows a select command of SQL. So what it does, it can only retrieve information. If you want to update, you want to delete, you have to do something else. It also does not allow command execution or wildcard for fields. So in a security context, we're lucky as we don't have to worry about as much. Before we move on to Soql injection, let's talk a little bit about SQL injection. So for those of you that don't know, SQL injection is an attack where user input is allowed to modify the structure of a SQL query and perform unexpected actions. What does that mean? So let's take this example. We have a classic example, a login page. So what this query does is it will take the username that the user has provided and the password, and it'll put it inside this query. So to get the user that you provided the username and password with, this is probably what it's going to look like. You're going to select all the fields from the user table where username equals to the user input, the username input, and password equals the password input. It looks all fine and dandy, but what happens if a malicious user decides to put in admin dash or single tick dash dash as a username? If we don't modify this user input, this is what it's going to look like when it's get passed inside the query. The beginning will look the same. When you get to where username equals, the single tick on the admin input ends the query prematurely, and the double dash comments out the rest. So the entire query basically ends at where username equals admin. And what happens here, when this query is made to the database, it's going to return all username, or it's probably only going to be one if the username is unique. So it's going to return the admin account without checking the password. So now the attacker can log into the administrator account without actually knowing the password. This is just a simple example, but it's possible to do really complicated SQL injection attacks that append to this original query. You can do unions, you can drop tables, and you can even do command execution if the database allows. So on Soql injection, luckily we don't have to worry about it as much. You can't do command execution, and the structure is a little bit more limited. So it only occurs if you use a dynamic Soql query without the proper manipulation, the proper sanitization of user input. So in this sample here, we have a query that's going to grab the ID from accounts where the name equals the user input. So very similar to SQL, we're going to take our query that's constructed with a string here, and we're going to pass that string into database.query, and we'll get the result. Normally, we expect the user input to just be a name, so a sequence of alphanumeric numbers or characters. But what happens if the user puts in single ticks and some other stuff like this? It puts in Bob, single tick, or annual revenue greater than something, or name equals Bob. The reason why we have this or name equals Bob is just to complete the query. So the final query is going to look like this. It's not only going to search for accounts where name equals Bob, it's also going to search for accounts where the annual revenue is greater than $1 million. This is going to come in handy when we talk about our vulnerability in the ForZip app later. So let's do a little bit of demonstration here. So we can see here that the ForZip user can't see the annual revenue. But what can we do to bypass that if there's SQL injection?
So we'll close our query. We'll do and annual revenue is greater than, let's say, 50 million, and the name is like that. So let's search. So here we're on an insecure page, so let's ignore that we've reverted all the way back. But on a page with Soql injection, we've been able to limit our search to only records that have greater than a certain amount. So if we do, so if we go and fix this, copy, refresh. So let's try that again. So here we see that even on our fixed page where we haven't fixed Soql injection, the annual revenue is not shown But using this logic, we're able to tell that United Oil and Gas is worth more than 50 million. If we add another zero, 500 million, so it's worth more than 500 million. Let's see if it's worth more than 5 billion. It's not. So what happens here is we could, through binary search, go and extrapolate the value of accounts, even though we can't see the annual revenue.
So how will we fix this issue? So like you know, the issue is with a single tick. The easiest way to fix this is just to use static queries instead of dynamic queries. So to use a static query, you'll put the query inside square brackets, and then you use bind variable where it's necessary. So in this case, instead of making it into a string, we'll put the query inside square brackets, and where we're putting in the search query, we'll use this colon variable. Another way we can fix this particular issue is to use string.escape single quotes. So what this does, it'll make the single quotes into, it'll escape the single quotes, so when you put it inside the string, it'll just accept it as data instead of part of the query structure. However, this won't prevent all the attacks. Let's say we have a query that selects ID from user where the user is active. And you escape the single quotes of the variable. However, if you put in true and receive admin info, then it will return not only user active, but also ones that receive admin emails. So now let's fix it. So we can see the issue is here in our query. We're not doing any escape, any sanitization on our search string. We're just putting it inside the query. And we have another one where we're actually using a static query with the bind variable. That's the correct fix. So all we need to do is to do escape single quotes on this string, and it'll fix the issue.
Cool. So that wraps up the Soql injection demo and how to fix that. So in summary, we've covered a lot of the best practices for respecting the authorization model. We talked about Crud, object level, FLS, field level, sharing, record level, permissions, and we talked about Soql and injection. So you want to be aware of access control violations and potential for Soql injection when you're writing Apex code. So we have some additional references, additional resources, which we'll distribute in the slides, and so we have secure implementation, Crud and FLS guides, with or without sharing, Soql injection, secure coding, etc. You'll see all of these. If you're in Germany in March, you can catch us at the security booth of the Salesforce World Tour at CeBIT. If you're in Chicago in March, we will also have a Trust presence at the World Tour there. And please share your feedback to this survey. We'll do our question and answer now. You can join the conversation on Twitter with Salesforce Devs, or for the our App Exchange security team at Secure Cloud Dev. So yeah, we'll continue with Q&A now, and please go ahead and share your feedback to this survey. And thanks everyone for attending. So.
Okay, so one of the questions was, what if you have 40 fields and you need to make Crud FLS checks? Yes, you need to be going through all the 40 fields and doing FLS checks because each and every field will have their own permission. One more question was, how can we give FLS in a permission set, not from the UI, but to the Apex class? I believe we have tooling API and metadata API, which allows you to do that. So you can write a piece of code which goes and gives FLS or Crud automatically using Apex class.
Yeah, so another question is kind of why isn't this default, or why are access control checks not done by default, or why can't there be an as user as system execution? The answer is it's complicated. It's a very hard problem to solve now that everything has been built. Apex was built with security in mind, but it also needed to have certain power to bypass access checks, basically. If you have a trigger, if you have batch classes, if you need certain functionality in your app, it can't always run in the user context. So it is necessary to have both, and basically the design decision was made that it should be this way, and it's a hard problem to solve. It's something that's on everyone's minds here, and we want to make things more secure by default, but it's important to keep in mind that Apex does need this power, so we can't necessarily go and disable it or do some of the easier things there would be to do. We had another question about FLS being enforced in Lightning components. Cool that some people are looking into Lightning apps and components. Basically, this will depend on the controller as well. Lightning's going to help with your UI and your rendering and all of that, but your access checks and your logic done in the background and your use of Salesforce objects will still be controlled by Apex controllers, and you'll still need to do those access checks. Oh, yeah.
Did anyone talk about
that? Okay, so there was a question about an object having 5 fields, and a manager will be able to see his own records, and there'll be some employees, and he can see all the 5 fields of his own records, but only 2 fields of employees. Yeah, you can do this using a Visualforce page. You can build up and do all the permission checks in the controller and pass on relevant records depending on the permission. And let's say, for example, you want to see only 2 fields, you can show only 2 fields instead of 5 fields. Oh, yeah.
Extensions.
Okay, so one of the question was, do extensions use standard controllers run in system or user context? So if you're using something like accounts as a standard controller or contact and not having a Apex class at all, then it does run under the user context, and you don't need to do an FLS checks. But if you're using any sort of extension, or if you're using any sort of custom controller for your particular Visualforce page, then you need to make FLS checks in your controller. That's also provided if you're doing some manipulation in Apex class, you're converting it to a string or a wrapper object. If you're not doing that, FLS checks are already done and you don't need to worry about it.
Yeah, and we have another question. What if your wrapper class has a property of an S object? Would Crud and FLS be enforced in Visualforce for those items? No, the very last one.
As a property of an S object. I mean, if you have a wrapper class, it's going to be like an object by itself, then no, it won't have. But let's say you have inside a wrapper class, you have an object you declare like an account, and that will have FLS checks. But if you the wrapper class itself, the object for the wrapper class won't have those checks.
Yeah, so a lot of these things can also depend on the particular way you're writing your application. So it's important to think through how your code is interacting with objects, how access control is happening. Any other questions?
There's one question about is queryable. Was that covered?
Oh, we didn't read it out loud. So yeah, one of the questions was
is queryable and is accessible? What's the difference? And can we use is queryable instead of is accessible? No, is queryable is for checking if the particular field can be used in a Salesforce as a Soql query, which is different than is accessible. Is accessible check if the particular user has permission to access that field. So both are 2 different things. You can't use that interchangeably.
Yeah. Yeah, I don't think it looks like there aren't any other questions. So yeah, thanks again everyone for attending. We'll release these slides, and we will also release the code for demo, so if you want to look it over, it's a pretty simple app, just one Visualforce page, one controller. You can put it into your developer org, you can get testing, you can see what happens when you're trying to exploit Soql injection or other issues, and you can play around with it. And this is also the app we'll be using for the rest of our webinar series. we're going to add some functionality to it and continue to discuss how we secure that functionality in the future. So yeah, thanks again everyone, and please tune in to our future webinars.